Okay. So the first thing that you have to have for this project is you have to have your ordered pairs all figured out. You can see not all of mine are figured out. There it is. I don't have all my ordered pairs figured out, but I do have enough to show you examples. You will have to have an absolute value, V shape. I am not going to go over that today. I'll go over that maybe Friday, but I'm not going to go over it today. We're just today going to go over horizontal, vertical, and diagonal lines, how you find the equations. I'm going to start with this pink part of my V. I colored it pink. I'm trying to stay organized. You have to turn in what we're doing right now. You have to turn for your name. You have to turn in the part that we're doing right now with all the work. So please make it organized, because if I have to pull you out and be like, I cannot figure this out, we're wasting time, both of our times. So make it organized so I can figure it out by looking at it. Some people decided they're going to kind of like have a space where they put all of their V equations. Okay, because to make the V, I need two separate equations, or one V shape, but I'm not doing that today. So we're going to make two separate equations. And then some people color code them. So you'll notice I colored in my V, and I'm going to write in pink so it matches. And then you'll see with the I, I've got a green one and I've got a blue one with the I as well. So color coding is helpful too. If you're using Kami, you literally could zoom in really, 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 really far and write small. You can always change over here with your pen. You could change how thick your writing is. So you really couldn't fit a lot on that if you're using Kami. If you're using paper, that's totally fine too, because then you just use as many pages as you need. All right. So we're going to start with finding the equation of the pink part of the V. In order to find the equation of a line, I'm going to start with two ordered pairs. We did this yesterday. This is a diagonal line. What do I need to know about this line to find its equation? We need points that it passes through, and there's how steep it is. And what has to do with steepness? Does anybody know? Slope. We need the slope. So if we have two ordered pairs and we need the slope, I just wrote my two ordered pairs down, and then I wrote the slope formula so that you have it in your notes. So what I'm asking you to do for notes is write down my ordered pairs, write down your slope formula unless you have it memorized, and then I'm going to go through everything we need to do for that pink line. So I've got my slope formula, y2 minus y1 over x2 minus x1. I'm going to plug in the ordered pairs, 2 minus 10 over negative 11 minus negative 14. Part of your quiz on Friday might be find the slope between 2 points. So you need to know how to do this for your quiz. Here we are practicing it. When you've got negative, negative, that means positive. So now I've got negative 8 over 3. Does that reduce? What's it reduce to? A mixed number? That's not reducing. That's just changing the form to a mixed number. Reducing would be, is there a number I can divide out of 8 and divide out of 3? No. So this does not reduce. I'm moving on. Remember, slope is a fraction. It is not a mixed number. It can be a fraction and improper. It can't be a mixed number. It can also be a whole number. So now I have my slope. If I have my slope and I have a point, I'm going to use point slope formula because I have the slope and a point slope. The formula from yesterday when we did this in our notes was y minus y1 equals m times, or parenthesis, x minus x1. I plug in my slope, my point x1, and my point y1. So I'm going to plug in, my slope is negative 8/3. My x1 is negative 14, and my y1 is 10. You can can use the other ordered pair. It doesn't matter which one you use, but sometimes the other ordered pair is easier. So I'm just letting you know. I just used the first one, but you could use the other one. Okay, the only thing I have to simplify for point slope form is the negative. So my point slope form is y minus 10 equals negative 8/3 x plus 14. That's point slope form. For the project, you have to put it into slope intercept form. Slope intercept form is the m and the b, the slope and the y-intercept. So we have to change that, and we went over that yesterday in notes as well. For the project, it has to be in slope intercept form. So you have to get rid of the parentheses first by distributing. So I have y minus 10 equals negative 8/3, and then I multiply that by x, and now I've got a teeny tiny little issue. It's not an issue, it's just an itty bitty issue. My itty bitty issue is I have to multiply negative 8/3 by positive 14. So I have to multiply a fraction with the whole number, which you can't do. You can multiply a fraction and a fraction. So I'm going to change 14 into 14 over 1. When we multiply fractions, we go straight across. On the bottom, I get an easy number. On the top, it's not as easy. So I'm going to go over how to do mental math. If you absolutely need the calculator at this point for 8 times 14, whatever. I'm not going to hold you back. But I do want to go over mental math because mental math saves time and it makes your brain stronger. What is your question? It is, but I'm going to go over mental math. I'm glad you got it. Did you do a calculator or did you do mental math? Or did you just like multiply? Okay, you can do it that way too. I'm going to go over mental math. Maybe you'll learn a nice trick. I use it all the time. So to do my mental math, this is what I'm going to do. I'm going to, first of all, negative times positive is a negative. Okay, so I know that. Let me move this over here. I know it's negative, and I know the bottom is going to be 3. On top, I'm going to multiply 8 times 14, but I'm not writing it as 14. I'm writing 8 times 14. Isn't 10 plus 4, 14? Yeah. Now, I actually do this in my head, but I need to show you it's in my head because you can't see it. So I do 8 times 10, which is 80. And I do 8 times 4, which is 32. And then I add those together, which is 1/12. So by taking 14 and making it 10 with something else, we can do mental math. And if you want to do mental math on something and you're not quite sure how to multiply those two, please ask. I would love to help you strengthen that brain, that big old muscle that's in here. It has to get worked out to get stronger. Okay, so here we are. Is this in the form of y equals mx plus b yet? No, because it doesn't say y equals. So I got to get rid of the 10. Get rid of the 10 by adding 10 to both sides. So now we have a small little issue again. I cannot add a fraction, an improper fraction, and a whole number like that. I need to make them both fractions. So 10 over 1. And we still have a problem. I cannot add fractions that don't have what? What? Same bottom numbers. What's that fancy word? Common denominator. We need the common denominator, which 3 and 1, the common denominator is 3. So I'm going to multiply the bottom by 3, but that means I also multiply the top by 3. So really, I'm adding 30 over 3. That's the same thing as adding 10. 30 over 3 is 10. So I've got a negative 1/12, adding 30. So we're making it more positive. It doesn't get positive. More positive, but not positive. I just add 10 at a time. So it takes it down to 102, to 92, to 82. Y equals negative 8/3 x minus 82/3. I purposely chose numbers that would give us fraction practice. You might not even have horrible fractions on yours, fingers crossed. Or if you start looking at your ordered pairs and you end up having horrible fraction for slope, you can always change your letter where it is, make it smaller, make it bigger, change the slope of it to make it easier on yourself. Again, you can ask me for help if you've got horrible numbers. You can also ask me for help if you do it and you're like, I don't know if this is right. I have a weird answer. Ms. Criswell, am I doing this right? And then I can look and see if you had any silly mistakes in it. Okay, but you got to do stuff in here. You got to seek me out and you got to say, Ms. Criswell, I need help. I cannot read your mind. You got to ask for it. Okay, this is the first thing you have to do for all of the lines you have, is you have to find the equation. That's the first thing. Now, when I find that equation, if you want to check it on Desmos, you can type in the equation, which I've done, to check it on Desmos. So I typed in the equation, but I'm zooming out. How is this equation different than the V that I had, or the one part of the V that I had on my paper? How's this equation different? Or this graph, I should say. Jaden? Oh, it's not on the 0. It's because I'm zoomed way far in. But out. I zoomed out so you could see why it's different. It doesn't end. Because I did not tell Desmos to make it end. I'm going to teach you how to tell Desmos to make it end, but that's not happening today. So if you want to use Desmos right now, just to check to make sure it goes through those points. I forget what my points were. There was like negative 11 something or 1410. Okay. There we go. It does go through that point. So if you want to use it just to check that it goes through those points, you can use that for sure. It just doesn't end. But you have to figure out where it needs to end. So I'm going to go back to my graph, or the notes that we're taking today. And you need to add on some restrictions. I'm calling them restrictions, but they actually have different vocab words, which you'll get in a second. Restrictions. So these are going to be called restrictions, but the real math vocabulary, what it says in your rubric, is you have to have the domain and the range of each of these. You have to have the domain and the range. That's what I'm going to use for restrictions. Have you guys, you don't have to tell me what they are. Just, you have heard of domain and range before. Anybody? You don't, I'm not going to call on you if you raise your hand. I'm not asking you to tell me. I'm going to tell you now what they are. I just want to know that you've heard of it before. Okay. So the domain has to do with the X values, and the range has to do with the Y values. I'm not putting domain and range on the quiz on Friday, but you have to do it for this project. So what we're going to do for domain is, you can look at the picture, you can look at the ordered pairs, and this is what you ask yourself. How far does this graph go left and right? Just the pink line, just the pink line. How far does it go on the X's to the left? How far does it go on the X's to the right? Now, I'm literally telling you what to look at when I say how far does it go on the X's. So what is the X on the left? Negative 14. What is the X on the right? Negative 11. It goes for the X's, for the domain, for the left or right, it goes from negative 14 to negative 11. So how we write that is, you say negative 14 is the smallest, less than or equal to X, less than or equal to negative 11. That's how you write that the x's are between negative 14 and negative 11. That's how you write that the x's are between negative 14 and negative 11. It's always less than or equal to, the x goes in the middle. Okay? The range is the y values. So I'm going to ask you the same question, only we're looking at the y's. What I don't want to do right now is walk around and make sure that you're not sleeping in my class. If you're sleeping in my class, you're not going to know how to do this, and good luck. That was a good thing. Good luck. Okay, so we're going to look at the y's. We start from the least to the greatest. We're looking at this pink part, and we're going to look at the smallest y and the greatest y. Look at the ordered pairs. What is the smallest y out of the ends? 2. What is the biggest y? 10. That's the range from 2 to 10. And we write it smallest number less than or equal to y less than or equal to 10. That's how we write our range. That's what you have to do for every diagonal line. Now, hopefully, like I said before, you won't have a horrible slope, because that's what made it take longer, was my slope. But I did that on purpose just in case you do have a horrible slope, you can still do it. Jaden, do you have a question? No, you're the one that's going to miss something, okay? So, okay, we got 2 more examples, and they're not as long as this, all right? Questions? So all of your diagonal lines, you got to do this way and find the domain and range. The next thing I'm going to do is go over a horizontal line. So that's the green one. So if you're taking notes, maybe you write how to do the horizontal line. My I value goes from negative 4,7 to negative 2,7. I'm just going to copy those down, negative 4,7 to negative 2,7. This is the horizontal one. Horizontal lines. You do not need to find the slope first. By the way, we need to know the slope of a horizontal line. The slope of a horizontal line could be on your quiz. Who knows the slope of a horizontal line? 0. Who was that? Was that Andrew? 0. Okay? That one does not go up. It does not go down. It goes straight across 0. What's the slope of a vertical line? Undefined. That's the one that you cannot ski. That's the undefined. The other one's the 0. So we don't need to find the slope, though. What we need to do is look at the ordered pairs. You see something in common? Is it Josh? You see something in common?
Yeah, both the y's are 7.
Both of the y's are 7. And if I picked any other ordered pair on this horizontal line, the y's would always be 7. We just found our equation, y equals 7. That's the equation of the line. So if it's horizontal or vertical, you don't have to find the slope. You just look to see what's the same. Y is 7. That's the equation. But if I go and I type y equals 7 on Desmos, I now have an issue because that goes on forever, and my I did not go on forever. So we need restrictions. Those restrictions are called domain, which are the x's, and range, and that's the y's. So I got to look at the ordered pairs for my domain and range. So I'm going to go back to the picture, and I'm going to look for my domain, which is the x's. And I'm going to ask somebody, and I'm going to call on somebody, and I think it's going to be Morgan. What x's does this go through? The x's. What x's does this go through? It goes from what to what? Yes, the numbers, yes.
-4, -3.
Oh, you don't have to tell me in between. It goes from -4 to -2. Because there's also decimals in between. There's infinite many numbers in there. We just have to say the ends. So she said it goes from -4 to -2. That's perfect. We just need to write it as an inequality that says -4 is first because that's the smallest. -2 is the end, is the bigger end. So that goes last. X is in between those. So that's our domain. And we got that from the ordered pairs. All right, and then we're going to do our range. Same kind of procedure. We're looking at what for the range? The y's. And I'm going to ask Junior to look at the y's and tell me that these ordered pairs go from what y to the other y. They go from 7 to 7. So they don't actually go anywhere. It's always 7. Don't we already know the y is always 7? The domain is the y's, and y is always 7. So literally for the domain in this one, you write y is always 7. There isn't anything else in the range. I said domain. I meant range. Y is always 7. So that actually looks exactly like the equation for the line. That's how you do horizontal, and that's all for that horizontal line. A lot less work than the diagonal line. Should be a lot easier. Last one we do together is a vertical. We're going to do the vertical line in the eye. My ordered pairs are -3, 7 and -3, 2. So I'm going to copy those down below. My stylus turned off for a second, so I'm waiting for it to turn back on. -3, 2 and -3, 7. Okay, that was messy. Let's try that again. All right, just looking at these ordered pairs. Jamari, just looking at these ordered pairs, is there anything you can observe here? Maybe something in common? The X's are what? Same, but what are they? What number? The X's are -3. That's your equation. For vertical line, X equals -3, done. We have our equation done. Horizontal vertical lines, all you got to do is look at the ordered pairs, see what's the same, write that as your equation. And then domain and range. So domain is the X's. I'm going to put the visual back up there. I'm going to go to the I itself. Although you can just look at the ordered pairs if you want. I need to look at my X values. And I need to know that the X's go from Janaya. I need to know that the X's go from what to what? -3 to -3. So do they really go? They just are. They just are. So X equals -3 is our domain for that one because they don't change. They're just always -3. All right. And then the range, we're going to go from our smallest y to our largest y. You can look at the picture or you can look at the ordered pairs. And Roro, can you help me? Tell me what the y values go from what to what? 2 to 7. Perfect. So you're going to set up your range going from 2 to 7. And that's how you do vertical. So now I'm going to turn off this video in a second. I just going to walk around and answer questions. If you don't know how to get like a V shape in there or whatever, I want you to start finding ordered pairs and working on it as soon as your name has already met all of the requirements. If it already has, you're good to go. You do need all the ordered pairs to do the equations and the domain and range. So you could start there. But before we go and do the scavenger hunt, I want to know that you can find the equation of a diagonal line, of a vertical line, of a horizontal line. I want to make sure that you know how to do that before you leave. I did make a video, so if you zoned out, you can go back and watch the video. I am not going to teach the entire lesson over again because you zoned out. You can ask me questions. I'm not going to teach the entire lesson again, okay? But I will post this video for you. Let me stop it.